Yes. Good evening, all.
Good evening, sir.
Good evening, sir.
Yes, Harshil. Good evening, Harshil. Harshil is asking what we are going to do today. Yes, guys. Shall we discuss the trigonometry?
Yes, sir.
Yes, sir.
Shall we go with? Are you guys ready?
Yes, sir.
Yes, sir. I'm ready.
Are you all ready? Tell me, make it fast.
Ready, sir.
Yes,
Yes,
sir.
I'm not getting that enthusiasm from everyone.
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Hmm. So I need a response from every one of you. Yeah,
Yes, sir.
I just get response
Yes,
from
sir.
very few students. Aditi and Harini,
Yes, sir.
Shreyan,
Yes, sir.
Harshil,
Yes, sir. Yes,
okay,
sir.
Modita. Very good, very good. Okay, so let's get started, guys. Let's get started with this trigonometry. So as per your concern, I'm starting with like few of the students are having exam on trigonometry. Okay. All right. So beta, tell me what do you mean by trigonometry? First of all, have you ever heard about the name trigonometry, or this is the first time you are hearing?
Sir, we did.
Sorry.
Sir,
Wait.
I did listen to it, but I'm not sure what it is.
So,
No,
like, I have listened to it, but like,
I know
it was
formulas and all. We
a few
did.
months ago. So, it's a kind of
Related to triangles.
sorry.
Pythagoras triangle.
Hmm.
Right angle.
Hmm. Very good. Okay, tell me. So yes. Like, I'm not getting response from every one of you. Tell me, have you ever heard?
Yes, sir. Trigonometry is used to find the height of the building.
So it is based on a triangle.
Basically, look at it here. You just
It
got
has
this
6
name.
ratios.
Yeah, you just got this name from the Greek language. Here, tri means beta 3.
3.
3.
Okay. Gon means geo in gon means like sides.
Metri means
Okay.
measurement.
Metron means
Measurement.
basically measure. Okay. 3-side measurement of a triangle is what? Trigonometry. So basically, we will be dealing with only right angle triangles. Very good, Dipsika. We'll be dealing with only right angle triangles in the trigonometry. Let me tell you what exactly they required. Okay. We will be dealing with what? Right angle triangle. Right angle triangle. We will be dealing with right angle triangle. All right. Yes. So yeah, now look at the board. 1 second. Right angle triangle. Right angle triangle. Okay. So now let us try to understand what exactly we are going to learn from this. Okay. First of all, let me draw a right angle triangle like this. Okay, this is A, this is B, this is C, and it is making some angle here called theta. Okay, this is making 90 degrees here. All right, beta, this is making 90 degrees here. So you just learned about triangles, and here this is what an angle. So, beta, have you ever heard about the angle can be measured in different ways? What are the ways? Angle can be this is what angle, right? What do you mean by an angle? What do you mean by angle? Tell me.
If 2 rays are joined at a point and extended in another direction. Then the amount of theta in which both are extending are known as angle.
Okay. So for suppose two rays or two, you say two lines shares a common endpoint. Okay, when two rays or two, two shares and two rays shares a common endpoint, that is what angle beta. All right. So the corner you say the angle is from which language it has been derived from the Latin language. So basically this corner, look at it, this corner is what angle we denote with a theta. All right, that angle can be measured in what ways beta? The number one measure, the angle can be measured in angle measurement. I'm talking about angle measurement. Angle measurement. This is going to be very interesting, guys. So I'm not going to teach exactly from your school syllabus. I'll be teaching you something advanced than that. So yes, in fact, we'll be touching your school syllabus as well, but in advance we'll be learning here. Okay. So angle measurement beta, this can be done in two ways. First one is degree measurement. In degree measurement, and the number two is radian measurement. Degree measurement and radian measurement. All right. So degree and radian measurement. Basically, degree means what? What is radian? So you'll be learning in class 11th again. Okay. Don't worry. You'll be learning again class 11th. So degree we denote as like this: 1 degree, 2 degrees, 3 degrees, and so on. Radian measurement is nothing but, look at it, I'll be writing like this: 1 to the power of C. Or you simply write it as, look at this here. I would be writing 90 degrees as what beta? 90 degrees as pi by 2. This is degree, this is radian. Pi by 2 is what? Radian. 90 degrees is what beta? Degree measurement. So on the, how do you represent? Okay, sir. Degree means on the head you will be writing a small 0, and radian measurement is nothing but on the head you will be writing a small c. All right, small c.
Sir,
That is
how
what
pi by 2, sir?
I'll tell you that. So beta, basically look at this here. What do you here? What do you? How do you represent 180 degrees as pi? Correct, isn't it? Do you know this?
Yes, sir.
You don't know this, right? So what is half of this? That's it. 90 degrees is equal to pi by 2. That is how. So
Okay,
this is
sir.
degree, this is radian measurement. Okay. You understand? I just gave you a basic example. So what are the ways? What are the different ways of measuring an angle? So degree measurement, at the same time, radian measurement. So this is what the basic measurement of an angle. All right, beta. So yeah. So now I'll just tell you one thing. Okay. So yes, now we'll talk about trigonometric ratios. The major concept we have to learn here is trigonometric ratios. What is it? Trigonometric ratios. What are the ratios we'll be having?
Opposite by
Any idea?
hypotenuse. Yes, sir. 6 ratios.
Cos, sine,
Cos,
tan,
sine, tan, secant,
sine, tan,
cosecant, cot.
Very good. Okay. Totally, you'll be having 6 ratios, beta. So why do we have only 6 ratios? Why can't we have only 4? Why can't we have 8? Why can't we have 10? Because there is only possibility of having only 6 ways actually. Only these 6 combinations would be possible. What are they? Look at it, let me tell you. This is what called as base. This is what called as perpendicular. Perpendicular. This is perpendicular or not? This is base. This is hypotenuse.
Yes, sir.
What is that? Hypotenuse. I simply denote. Look at this here. This is with a capital P. This is with a hypotenuse. Okay, beta. Now here I'll just tell you one simple thing. So there are 6 ratios I told: sine theta, cos theta, sine theta, cosine theta, tan theta, tangent, okay, tan theta, okay, next cot
Cosecant,
theta, okay, secant theta,
secant,
cosecant. All right. So basically, sine theta is nothing but here sine theta is nothing but beta opposite
by hypotenuse.
So opposite by hypotenuse. We say opposite by hypotenuse. Okay. Opposite is what is here? What? See, sine theta. This is theta here. Okay. This is theta. What is opposite side to the theta beta? P.
C.
Alright. P. Perpendicular.
P
Opposite
by
to
H.
perpendicular. H. P by H. So P is what now? BC. By H is what? AC. Can I write like this? Very simple. Need not to remember all this, beta. Need not to remember. You just try to know what is sine theta is nothing but perpendicular by hypotenuse, which is nothing but opposite by hypotenuse. Okay. What is cos theta? Adjacent by hypotenuse. Adjacent is nothing but base, beta. Here, adjacent. What is the adjacent side of that? Theta? Base. Base by hypotenuse. Base is what, beta? AB. What is hypotenuse? AC. All right.
AC.
Very simple. Right? Everyone try to listen to me. Very important topic. Okay. Okay, guys. Tan theta. What is tan theta? Tan theta is nothing but beta.
Perpendicular by base.
Yes. Basically, tan theta can be written as sin theta by cos theta, beta. How? Sin theta by cos theta. So if I divide these two,
Hypotenuse common.
yes. Basically, I'll tell you here. Here, sin theta and cos theta are like mummy daddy. These two are like mummy daddy. These are advanced functions. What are they? I'll tell you one thing. Everyone, look at this here.
Advanced functions.
Yeah, these are advanced functions. Advanced ratios. Trigonometry advanced ratios. Okay, you are calling this as now ratios, beta. In class 11th, you will be calling this as trigonometric functions. Sir, why you are calling with the trigonometric functions in class 11th and why you are calling them as trigonometric ratios in class 10th? Now we are calling with trigonometric ratios because we are dealing with simple geometry. We are not using any complicated geometry. We are not using any, coordinate geometry here. We are using a simple geometry and we are, deciding what is sine theta opposite by hypotenuse and all, right? Yes, we are using a simple geometry and deciding. So next year you'll be using advanced geometry to say what is sine theta, cos theta, everything. All right. So sine theta and cos theta are advanced ratios, and remaining ratios are derived ratios. What are they? Derived ratios. From where? From sine theta and cos theta
Sine and
only.
cos theta.
From sine theta and
Verse.
cos theta
Okay.
only. These all has been derived, beta. Okay. So these all has been derived from where to where? From sine theta cos theta only. Cool. Yes. Now sine theta is what here, beta? P by H. Okay. Cos theta is what here? B by H. H will get cancelled. What do you get now? P by B. P by B. P is what here? AB. Sorry, BC. BC
C by
by.
AB.
All right. You understand my point? Any doubts?
Yes, sir.
Very simple.
No,
Right?
sir.
Now let's talk about this. Let me copy this. These are like sine theta and cos theta are mummy daddy. They are most lovable angles. They are most lovable ratios. So from those two ratios only every ratio has been derived, beta. Let me give a clarity to you all. So I'm just teaching in a comic language. Why? Because you need to remember why it is happening like that. All right, just a minute. I'm not able to erase it. I think people are waiting here. This Bhargav is always late to the class. I don't know what's happening with him. Let me counsel him 1 second. Very good, Dipsika. Look at this here. Bhargav, why are you late, Bhargav?
Sir,
Bhargav,
I
ji, why are
had
you
to
late?
restart my computer, sir,
Sorry?
due to some sir, due to an internet.
Bhargav, you
Sir,
can't give me
like
this excuse, Bhargav, every time. I have been observing every time you are so late to the class. Yeah, I'm sorry, you can't give me this excuse every time. Not acceptable.
sir, this time really, sir.
1 time, 2, 3, 1, 2, 3 times is enough, beta. So every time you can't give me the same. We are starting with a new topic. You missed all the top concepts now. Okay. So no problem,
Sir,
beta. Look.
trigonometry I know, sir.
Okay, so tan theta is what here? Sin theta by cos theta. So you can say that I know opposite by base. Basically opposite by adjacent, you can say. Cot theta is nothing but beta. Cot
1 by 10.
theta is 1 by tan. Actually
Opposite of
reciprocal.
tan.
Reciprocal of tan actually. Okay, so 1 divided by tan function is what now? BC by AB here. So can I write this as AB by BC now? Isn't it? Very simple. All right. Hope you are getting my point. Now let me tell you one more beautiful fact here.
1 by cos.
Secant theta is what? Reciprocal of cos actually.
1 by cos.
1 by cos. Cos is nothing but what, beta? AB by AC, right? 1 by
1 by AB
AB
by
by
AC.
AC, which is nothing but AC by AB. Okay. Cosec theta is nothing but 1 by sin theta. Sin theta is what here? BC by AC, right? 1 by
BC by AC.
by AC is nothing but AC by BC. Cool. AC by BC. So This is what the trigonometric ratios. Okay, I'll just tell you who all are like here sine and cosec will be reciprocal to each other. One second. Cos and secant and tan and cot will be reciprocal to each other. All right. So hope you all got the point here. What I'm trying to say. So let me write here reciprocal functions. What is the reciprocal ratios? So here sine theta can be written as 1 by cosec theta. 1 by cosec theta. And at the same time, cosec theta can be written as 1 by sin theta. You understand my point? Now, cos theta can be written as 1 by secant theta. At the same time, secant theta can be written as 1 by cos theta. So, tan theta can be written as sin by cos. Or you write this as 1 by cot actually. 1 by cot. Is it clear? Is it clear?
Yes, sir.
Now, beta,
Yes.
just now I told you that note. Everyone take a note here. Tan theta is nothing but sin by cos I told. Tan theta is nothing but sin theta by cos theta. Now what is cot theta? Cos by sin. Can I say like this? Can I say like this? Tan theta is sin theta by cos theta. Cot theta is cos by
Yes,
sin.
sir.
All right. Yes, very simple.
So can you scroll up to reciprocal ratio?
Reciprocal ratio is nothing but sin theta can be written as 1 by cosec. Is it clear?
Yes.
Basically, you can say that relation between trigonometric ratios as well. You can say relation between, instead of reciprocal ratio, you can say that relation between trigonometric ratios. All right. Relation between trigonometric ratios. All right. Yes. Now look at the board. So yeah, got it. So now let us try to understand. Let us try to understand the visualization of trigonometric ratios by using a unit circle. What is it? Visualization of trigo means trigonometric ratios using a unit circle. Okay. So basically what happens is, beta, look at it, you just draw a circle. I'll show it to you. Okay. Draw this circle. This is my y-axis. This is x-axis. Okay, let me take any point here. So let me take some, I just drawn this, circle is some radius, right? Let me take this as a radius. Okay. Getting my point. So this is origin, of course. Let me take some point here. Any point called P. Okay. So here it's making an angle called theta with x-axis. Okay. So I have just drawn a perpendicular. This is point P. I have just drawn a perpendicular from the point P like this. Clear? To the axis, and it is cutting at point called Q.
Yes, sir.
Clear? Very simple. Now everyone look at the board. 1 second, guys. I have to charge it. Just a minute. Please be in line. Sir, I'll share these notes, Dipsika, do not worry at all. I'll be sharing these notes, entire notes. Don't worry. Okay, people. So this is a point P, correct? So this beta, look at this here. This point P. So this is cutting the x-axis at called a point called Q, right? Now everyone look at this here. So unit circle, I said unit circle is nothing but beta. The radius of the circle is going to be unit beta. This radius is going to be what? 1 unit. 1 unit. Cool. So 1 unit. All right. Yes. So beta, this length is going to be red. This length I'm going to consider it as what? Sin theta. And this length is cos theta. Okay. This length is red. This is cos theta. Okay. So this point denotes what now? That point P is what now? Sin theta comma cos theta or not? Sorry, cos theta comma sin theta or not? On the x-axis we have cos theta and y-axis sin theta. So sin theta, cos theta comma sin theta or not? You understand my point? So now you visualize this beta. This is perpendicular here. This is 90 degrees perpendicular. Now look at this. I'll just simple give you sin theta is nothing but what? Sin theta is nothing but what? Opposite PQ by
VQ by
BC by AC.
OP. All right. So OP is what here? PQ. OP is what beta? 1 is equal to PQ. Getting my point? Sin theta is what now? PQ. I'm taking the hypotenuse. I'm taking that unit radius as what? Radius is as your hypotenuse, which is 1 here. So I'm just writing this as what? PQ. Sin theta is equal to PQ. Cos theta is equal to what now? OQ. OQ by OP. Again, OQ by 1 is equal to OQ. Okay. Tan theta is what? PQ by OQ, which is nothing but PQ by
OP.
OQ, which is nothing but you can say PQ is what beta? PQ is what beta? Sin theta or not? Check karo.
Sin theta by
Sin theta by cos
Yes, sir.
theta. This is how
sin
we are
theta by
getting.
cos theta.
This is how we are getting tan theta as sin theta by cos theta. Clear? So next cosec theta. Let's talk about cosec theta. Cosec theta is nothing but what beta? OP by PQ. OP by PQ or not?
Yes, sir.
So OP by PQ. I mean OP by PQ. How did you write, sir? I wrote reciprocal of sin beta. That's it. Reciprocal of sin. I wrote. That's it. So OP is what here? What here? 1. 1 by PQ.
1 by sin.
1 by PQ. So now secant theta is what? Secant theta is what? OP by OQ. OP by 1 by OQ. All right. 1 by OQ. So cot theta is equal to OQ by PQ. So which is cos theta by sin theta. So this is how we can just visualize by using this unit circle, and this is how we got that.
Sir, can you scroll
Sir,
down?
Sir, okay, sir. We are visualizing with circle, but why did we draw triangle in this? Sir?
Sorry, I have
Sir,
drawn
in
a
this
triangle.
circle,
Yes,
why?
yes. Why? Because trigonometry is all about measuring a triangle. That is why we can't deal with only circles in trigonometry. Trigonometry is all about drawing triangles. So without triangle, you can't imagine the trigonometry. Trigonometry is not possible without triangle. That is the basic reason. You don't have any reason more than that, Bhargav. Getting my point? Yes.
Okay, sir.
Now actually, yes, beta. Look at this here. So you need not to learn all this actually, but for the starting time, for the first time you are learning all this. So I'm just telling you all this. Now, beta, you have very important, ratios. You have, as I told you, ratios is nothing but you will be having every value, beta. Look at it, you will be having sin 0 degrees, sin 1 degree, 2 degree, 3 degree, till infinite. You'll be having all the values. If I say beta sin theta, in place of theta, you can substitute any real number actually, any real number, -1, -2, 1 lakh, 10 lakhs, trillion, million, that, any number, everyone will be having a value, but we need not to learn all the things as per your syllabus. We'll be learning only few things. As per that, we'll be moving ahead better. Okay. So first of all, let me write the values, few values I'll be writing. I'm sure you will be aware of that box actually. So this is a trigonometric ratio. I'll be writing here, a ratio and degree here. And the ratio, sin theta, cos theta.
So we can substitute only till 360 degrees, sir, or till infinity.
You can look at it here. You can find out like any value actually. Let me say 1080 Sine 1080 is what? Sine, 9, you say sine 830 is what? I mean 840 is what I would say. So there are certain, rules and regulations. How can you find out these big values? But till 10th standard, you'll be learning only few things. I'll teach you them as well. Don't worry. So cot theta, secant theta, and cosec theta. Right. First of all, let us run only few things. I'll teach you everything. Don't worry. 45 degrees, 60 degrees, 90 degrees.
90
So
degrees.
you'll be learning only few this will be you'll be learning all these values, and in the next academic year, in the 11th standard, you'll be learning the big. But I'll be teaching you all of them very simply. Don't worry. Very easy, very interesting as well. Okay. So now here you need to make sure that sine 0 degrees is what, beta? 0 only. Okay. Sine 30 degrees is 1 by 2. This is 1 by root 2. This is root 3 by 2. Sine 90 is 1 actually. Okay. Sine 90 is 1. For cos, what you have to do? You have to follow this way actually. Reverse order you have to write. Reverse. Look at it. First I'll be writing
1
1.
root 3 by 2, 1 by root 2, 1
1
by
by
root
root 2, 1 by 2,
1 by
0.
2, 0. Getting my point? Now, tan 0 is going to be what? 0 by 1 is 0. 1 by 2 divided by root 3 by 2, 1 by root 3.
1 by root 3.
So here 1 by root 2 by 1 by root 2 is 1
1.
actually. So here
1.
root 3. Here how much? Not defined. Not defined is 1 by 0 is basically what? Not defined or not? Infinite we write. We write this as, we write that as what? Infinite beta. Correct? Alright. Now cot theta is what? 1 by tan. Cot theta is what? 1 by tan. 1 divided by 0. 1 divided by 0 again
Infinite.
not defined.
Undefined.
Reciprocal of tan is cot, right?
Root
So,
3.
root 3 here.
Root
Reciprocal of 1
3.
is 1. Reciprocal of
1.
this is what? 1 by
1 by root 3.
here reciprocal of 1 by
Sir,
infinite
cot
is what?
45 is not defined, sir.
Sorry?
Sir, cot 45. 1 by 1 equal to 1.
1 by 1 is not defined.
Sir,
1
1 by 1 is 1 only.
1 by 1 is 1, man. Look at this. So secant theta. Secant theta is what? Reciprocal of cos. So 1 by 1 is 1. 2 by root 3. Root 2. 2. And here, tell me. 1 by 0 again not defined. Now cosec theta is what? 1 by 0 not defined. Here 2. Root 2. 2 by root 3. 1 here. Sir, how did you get this 0? Tell me. How did you get that 0? Tell me. Cot theta. 1 by infinite. 1 by infinite is what? Arey yaar, 1. You are dividing with a big number. Dividing 1 with a big number, what happens? You get something 0 point something, isn't it? You getting my point? Hello? Tell me guys, 1 by infinite is exactly 0.
Yes, sir.
Yes, sir.
1 by infinite is exactly 0.
No, sir.
1 by infinite, beta, 1 I divide with a big number. What you are going to get? You are going to get 0.0000 something. I mean, you will be getting something called 0 plus. I mean, slightly greater than 0 you will be getting. Correct? You'll be getting slightly greater than 0, but not exactly 0. But in mathematics, what we do is we'll take, approximately that as 0. We'll consider that as 0. But that actual real fact is 1 by infinite is 0 plus. We take it as 0 plus. Okay? Getting my point? All right. Any doubts? So that is why I wrote 0 here. Hope you all are getting my point. What I'm trying to say here. Is it clear or not,
So
guys?
what is this?
Huh?
So what is a stable called, sir?
What is that?
What is a stable called?
This table is called as trigonometry value table.
Value of trigonometric ratios.
Value of trigonometry value table.
How did we get it actually?
Actually, we will be getting each and every value will be having a proof. Actually, each and every will
These
be
are
having
the
a,
specific values.
these are the specific values. For everything, we will be having a proof. Okay. So as per your thing,
Yes.
you can just prove all of this, but it is not required. It's not required. You can prove, if you prove one thing, where remaining things are very easy actually. All right. So now shall we prove that? Shall we prove that? One thing. We'll prove that. First of all, let us go with
Okay, sir.
trigonometric ratios of 45. Let's prove this 45. Okay. Then we'll prove 30 and 60 as well. Don't worry. Okay. 45. So you take a triangle like this. A, this is 90 degrees. This is B. This is C. Correct? Here, common sense, I would just ask a simple question. This is 90 degrees here, right? How much this angle is going to be?
Less than 9.
40.
45, 45, can I say?
45, 45.
Yes, sir.
Right?
45.
40, there should be, look at it here. 45, 45. Now, sum of A and C should be 45, 45. Can I say A and C 45? Let's say that. Let's say that triangle ABC is a right angle triangle. Triangle, here, one second. Let's say the triangle ABC is a right angle triangle such that angle A is equal to angle C is equal to 45 degrees. Cool. So now let's say that I'm just giving you this, this thing. This is, let's say consider this as A. This is also A. Let's consider A or any variable you consider it as. Okay, let's say that. Okay, can I use Pythagoras theorem now? By Pythagoras theorem. Pythagoras theorem. What we have here? Hypotenuse square is equal to base square plus height square. All right, beta. So AC square. AB is what I took, A square. BC is what? A square. Cool. Cool. You understand? Yes.
Yes,
So now
sir.
AC square is what, beta? 2A square.
2A
AC is
square.
what, beta? Root 2A.
Root 2A.
Correct. Now look at this. Let me give you one more. What we are finding is sine 45 degrees. We are finding. Let's find 45 degrees. I'm talking about, right? Let us talk about sine 45 first. Okay. So this in place of theta, what I have, beta? 45 have. So can I write this as opposite by hypotenuse? Correct. Sin theta is nothing but opposite by hypotenuse or not?
Yes, sir.
So here opposite, you can write this as opposite side to the 45 degrees all divided by hypotenuse. All divided by hypotenuse. So what is opposite side to the 45 degrees here? What is opposite side? BC or not, beta? Here 45, beta. This is a 45. This is 45. I think I should make the triangle somewhat large. And I should draw somewhat big. Okay. So BC by AC or not? Is it clear? BC is what, beta? A.
Yes, sir.
AC is what? What is AC, beta? Root 2 times of A. A you got. Cancel. So sin 45 degrees, how much you got? 1 by root 2. Check kar lo. Isn't it your value? Look at this. Sin 45. That's how I wrote that. Getting my point, beta? You understand, Harini ji?
Yes, sir.
Sir,
Now similarly,
yes.
cos 45, can you prove that? Cos
So,
45
but where did where did we get that root to AC value?
Hello, AC value I got, beta. I just substituted here. BC value I took A.
Okay, sir.
BC, where is the BC value? Where did I write that? This, look at it here. BC value I took A. This is A. This is also A. I just substituted. Where did we get? Where did we get?
Understood.
We got here, Maha. Where did we get means like we got here. AC value I got that. I just substituted here. BC I took A. A got cancelled. That is 1 by root 2 I just left with. Clear?
Yes, sir. Clear.
All right. So cos 45 is also going to be same thing. 1 by root 2 only. Cos 45 is what, beta? Base, adjacent by hypotenuse. Adjacent is what? A. Hypotenuse, what I got? Root 2A. A will get cancelled again 1 by root 2 or not? Same story for cos 45 as well. Now, sin 45, cos 45. Can't you find out tan 45 from that? 1 by root 2 divided by 1 by root 2, which gives you 1. All right. Hello, is it clear?
Yes, sir.
Now,
Yes, sir.
now sin 45 I got from the diagram. So now tan 45 is what, beta? 1. This divided this will get cancelled. I'll get 1 or not, Babu? Yes or no? Yes. Now tan 45 you know, sir. Very good. Cot 45 what, sir? Now 1 by 1 is 1, sir.
1.
Right, sir. Now sin 45 is 1. Cosec 45 is what now? Reverse of that root 2.
Root
So you
2.
know cos 45. Secant 45 is what now? Root 2 or not?
Root 2.
Yes, khatam. Kahani khatam. Isn't it? All right. Any doubts?
Yes, sir.
No,
No,
sir.
sir.
So this is how you just got 45 degrees of all functions. Hope you're getting my point. Hope you're getting my point. Shall I go with the 30 and 60 degrees now? Trigonometric ratios of 30 degrees and 60 degrees. Very simple, beta. This is a common story. Okay. So let me take a triangle. So 60 degrees, like, if I talk about 60 degrees, beta, what do you get? Equilateral triangle. Am I correct? Hello, guys. Equilateral triangle, isn't it? Mostly we'll be dealing with right angle
Yes.
triangle, but to prove this, we'll be taking help of equilateral triangle. Let's say this is A, this is B, this is C. Okay. Let me take this as what? 60 degrees. Of course, this is an equilateral triangle. This will be 60 degrees. And this will be what, beta? 30, 30. Is it clear? Yes or no? Equilateral
sir.
triangle. Now let me take beta.
Yes.
So first of all, let ABC is equal equilateral triangle. All right. Here AB and BC and AC. Both will be what? All sides will be equal. Getting my point? So A. So can I take 2 times of, let's consider this as 2A. Such that I took all the sides are equal. So I took it as 2A. Correct? Now all the angles we know that angle A is equal to angle B is equal to angle C is equal to 60 degrees. Correct? I have just drawn a perpendicular from A, where to where? A to BC, and it is intersecting at a point called D. All right. See, you have 2 triangles here. Can I say now here triangle ABD is congruent to triangle ADC? Why they are congruent to each other? Tell me. Hello.
Because angles.
Angles are equal, sir.
By using CPCT, can I say?
Yes, sir. By using.
You have learned. So here BD, I mean AD is a common side for both the triangles. BD is equal to DC or not? BD is equal to DC or not? Yes, it is perpendicular bisector. It divides into equal pieces. BD is equal to DC. All right. Now can I say angle BAD? Bad is equal to what? CAD.
CAD.
All right. BAD is equal to CAD. ठीक है, both 30-30 है. All right. So now, so BAD is equal to how much, beta? 60 degrees, 30 degrees here. This is also 30 degrees. Okay. And now, by using Pythagoras theorem, look at it here. By using Pythagoras theorem, can I say AD square is equal to AB square hypotenuse square, right? Yeah. So can I say that AD square is equal to, let me directly, AB square minus BD square, base square plus height square is equal to, look at it here. If you don't understand like this, let me write like this. AB square hypotenuse square is equal to base square plus AD square. Correct? Is it clear? Now can I say we need what, beta? We don't know AD, right? We want AD. Let's find out AD square. AD square is what, beta? AB square minus BD square. Cool. AD square how much? AB square how much? AB square. AB. 2A. 2A square minus BD square how much? a square. All right. I'm talking about AB beta. AB, this is fully 2a. This is a. This is a. This is fully 2a. Hope you are getting my point. Okay. All right. So now, so what you're going to get now? AD square is equal. Simple. 4a square minus a square, 3a square. 4a square minus a square is equal 3a square. AD is equal what now? Square root of 3a. All right. Now this is what I got. Now we'll do one thing. Let me copy this triangle. We'll use trigonometric ratios concept now. I'll observe the trigonometric concept. What is sine 30 here? What is sine 30? Sine 30 is what beta? Opposite. Opposite. What is the opposite side to the 30 degrees? BD or not? By hypotenuse. Hypotenuse is what? AB. BD is what? A. AB is what? 2A. 1 by 2 or not? Check kar lo. Isn't it? Hello? Sine 30 is
Yes.
1 by 2. Look at it here. Where is that? 1 by 2 I wrote here. Similarly, you can prove all the values beta. You can write sine, cos 30, tan 30, everything you can write. If you write sine 30, cos 30, very easily you can write for everything. Cos 30 is root 3 by 2. That's it. If you know these two values, tan, cot, cosecant, secant, everything you can write very easily. All right. Again, same story with the 0 ratios
Yes.
and 0 degrees
Yes,
and 90
sir.
degrees also. And similarly, you can go with the 60 degrees as well. 30 degrees I have just shown you how to proceed with that. 60 degrees also you can just think in the same way. All right. Similarly, 60 degrees also same way. Sin 60 is what again? Opposite by hypotenuse, same, and so. Very simple story. All right, beta. So this is not required. I'm saying this is not required, but you just got a clarity how we just can derive all this. Is it clear with everyone?
Yes, sir.
Now I'll just give you beta a range of trigonometric functions. A range of I'll tell you one thing here. For suppose you have this is your, let's say that I told you angle is nothing but what? At the end point of two lines or two rays, right? End points of two rays or two lines. Let's say this is your let's say this is your initial line. Initial line. Let's say this is your terminal line. This is terminal line, and you are getting some angle for theta here. Okay, beta. If this now, if you are moving in this direction, what direction is this? This is anti-clockwise direction. What is this? Anti-clockwise direction. If you are moving in anti-clockwise direction, theta should be what, beta? Positive. Remember this. Everyone, take a note. If you are moving in clockwise direction, something like this, clockwise. Theta should be negative. Getting my point? Anti-clockwise is nothing but theta positive. Clockwise direction is nothing but theta negative. All right. Getting my point? Yes. This will be very helpful. Just take it as a note. Sir, I have one more doubt here. Okay. If I just increase this theta, what happens? If you go this here, what happens? If your initial line is here and terminal line is somewhere here, beta. It is more than 90 or not now? Greater than 90 or not? All right. If I make a straight angle like this, how much angle it is making? This is a straight angle. Straight angle. This is more than 90. This is 180 degrees or not? Yes, I'm sure you have learned in lines and angles in class 11. Now, if I just move like this, it will be more. What is this? It will be somewhere, theta lies between, this is my theta here. Theta lies between where to where now? Theta lies between where to where? Hello? Theta lies between where to where? 180 and
180 and 360.
270 here, 270 here. Getting my point? All right.
Yeah,
so
sir.
no problem. Or else theta lies between 180 and 270, you say. Now, if I make something like this, What is this? Theta lies between where to where now? Theta lies between where to where? Beta, you will be, let me tell you, this is 0 degrees. This
0
is
and
90 degrees. This is 180 degrees. This is 270 degrees. Okay. This is 360, 0 degrees, comma, 360 degrees. This is 90 degrees. This is 180, 270, 360. So full circle. If I make a full rotation, that gives me what? 360 degrees. All right. Here theta lies between where to where now? This theta lies between where to where now? 180 and sorry, theta lies between where to where now? 270 and 360 or not? If I make a full circle like this, that is my 360 degrees. What is this? Theta is equal to 360 degrees or not, beta? Any doubts?
no,
Hello.
sir.
This is, if I make a note like this, beta, this is 180 degrees. This is 270 degrees. This is 360 degrees. Now, isn't it this theta lying between 270 and 360? Don't you accept with my point? Guys, tell me, don't you accept with my point or not? Tell me, 270, it lies between 270 and 360? Of
Yes,
course.
sir.
So I'm just telling this as initial line, this as terminal line, this as initial line, terminal line. So the angle between initial and terminal line is somewhere between 270 and 360. You got this. Okay, sir. My initial line is something like this. My terminal line is something like this. I make an angle like this. Okay. I make an angle like this. Now, sir, the angle can be made up to 360 degrees or it can made up to 720, 820, 920, 1000, 1 lakh. Yes, beta. You can make up to any. Look at this. I'll tell you one thing. If you're just starting with this,
Sir, then how can we represent it, sir?
I'll just tell you. I'll just tell you. Don't worry. It can be start here. It can be start here. Like it goes, and it can somewhere end here. Understand my point? Anyway, it theta can tend towards infinite actually. Understand my point? I'm just moving in what direction now? This is anti-clockwise direction. So theta can move towards infinite. It can make infinite angle actually. Getting my point? Now look at it. Your initial line is like this, and your terminal line is somewhere like this, and you are moving in clockwise direction like this. Check kar lo. You are moving in clockwise direction like this, like this. This is clockwise. This is anti-clockwise. Hope you are getting my point. What I'm saying. This is something advanced than your 10th book. Okay. Now theta moves what, beta? Theta moves towards minus infinite. As I told you, this is anti-clockwise. I mean clockwise, right? Clockwise. This is anti-clockwise. Getting my point? Anti-clockwise means theta positive. Clockwise means theta negative. So now, can I say from these 2 points, can I say that? 1 second, let me erase this. From these 2 points, can I say that theta lies between minus infinite to plus infinite? I mean, it can tend towards minus infinite and at the same time plus infinite. So it might lie between minus infinite to plus infinite. There is a chance. You understand my point? Hello, guys. Is it clear? Hello?
Yes.
Yes, sir.
Yeah.
Clear.
So basically, this is how, this is a basic, this is a very, very basic actually. So you just learned what you learned today. We learned about trigonometry introduction. What is trigonometry? What are the ratios we'll be learning in the trigonometry? And guys, till 10th standard, you'll be learning up to only 90 degrees. Let me show you. Up to 90 degrees actually. Look at it. Up to 90 degrees. So if you go to 11th standard, sine 180 is what? Sine 270 is what? Sine 360 is what? Sine 120 is what? Sine 150 is what? Sine 220 is what? Sine 540 is what? Okay, every angle. Now cot 540 is what? Cot of minus 1080 degrees is what? Or secant of minus, secant of minus 1710 degrees is what? All the big angles you will be learning better. I'll be teaching in this class itself. Don't worry. But you have to be thorough with all these basic concepts. Then only you can learn all that stuff. Okay. So don't worry. I'll be teaching you. So have another class. So this is the time to retire now. So we'll make a move now. I'll be sharing these notes. Please do revise these notes and come to the class. Don't leave the class. I'm just still speaking. Don't leave the class, I say. I'm still, guiding you something. You must listen that. You can't simply leave that. You can't wait here to simply leave the class. If that is the case, you may don't join my classes, please. I'm telling you straightforwardly. If you are here to simply leave on time, See, as soon as teacher ends the class, you may leave. Until I leave the class, you must be in the class, no matter what. Simply people are leaving, and I'll take an action who left the class. So I'm telling you, if you have an urgency, you put a message. I'm still talking. If you have any urgency, put a message. I have, may I leave 5 minutes before? Put a message. That would be the, proper way to behave in the class. You can't leave simply like this. Okay, people. Okay, children. So this is what the session is all about. And I would like to ask a question to each and every one of you, please. I would like to ask a question to each and every one of you tomorrow. Make sure that you are revising the notes and coming to the class. And homework will be uploaded today. Homework on a pair of linear equations only. There are certain questions to be solved. I'll be sharing those questions as well. Please, everyone, solve it up. And as I told you, no one is sending me the homework update. Sir, I have done homework. Please put a message, update. Just update me. Okay. Thank you. Goodbye.
Sir, wait, sir.
Yes, Bhargav.
Sir, tomorrow on which topic will you ask questions? On
Same
which
topic,
chapter?
whatever we have covered so far. Same topic,
Okay, sir.
whatever we have done so far. Okay. Thank you. Same trigonometry. I'm talking about
Trigonometry,
trigonometry.
right, sir?
Okay. Thank you.
Okay, sir.